for an inequality, will I ever have a solution that will be like x equals 3? Will that ever be a solution to an inequality? No, because that says x has to be 3. Inequalities are going to be some range of solutions. I could have something like x is greater than 3. So it could be 4, it could be 5, it could be 6, it could be 3.1. So inequalities represent a range of values. So make sure you get that straight when you're solving inequalities. Do not tell me x equals 3. It's going to be something along the lines of x is greater than 3 or less than 3 or less than or equal to, whatever. Okay? But to actually solve inequalities, we do treat them pretty much like an equation, but then we just have to be careful. If we multiply or divide by negative, that switches the sign. So let's go with this one. So if I want to solve this, I would subtract 5, and so I'd have a negative 3x. Negative 7 minus 5 would be a negative 12. Okay, now I want to divide by this negative 3. So that should throw up an alarm, a red flag, something in your head. I'm dividing by a negative. I need to reverse this inequality symbol. And so this becomes x. And then if I divide this side, negative 12 divided by negative 3 ends up being a positive 4. So x is less than 4. Make a note in your notebook. If you ever multiply or divide by a negative, you must reverse that inequality symbol. Do not forget to do that. Okay, so this is our solution. X has to be less than 4. It can be all the way up to 3.999 repeating, but as soon as I hit 4, that's no longer a solution. So if I were to graph this, I'm going to set just 0 on my number line. And so I have 4 here. I want values of x that are less than that, so I know I'm going to be shading left. And it cannot be 4, so that's an open circle on 4. If this was x is less than or equal to 4, then I would fill in the circle. That would be a solid circle. So this is solved, graphed, and then the next piece I have on here, write the solution in interval notation. So interval notation, this means that range of x values. Okay? So I know this is going as small as I want to go. So this would be going all the way out to a negative infinity. All the way to 4. So I read this. This is not a coordinate point. This is interval notation. Now we have options of a parenthesis, or we can have brackets, or we can have a mixture of one and then the other one. So there's 4 options that we have with interval notation. Any sort of parentheses means exclusive or excluding. Let's read it as excluding. Okay? We can never include infinity because we can never reach infinity. So if you ever have an infinity or a negative infinity, we're not going to include it because we can never reach that. If we have a bracket, that means including. So a bracket is going to come if you have less than or equal to or greater than or equal to, or if you have a filled in circle on your number line. This one, we do not have a filled in circle, and so this one is going to also be a parenthesis around 4. If it was a filled in circle and we were including 4, then it would have been that square bracket. All right, and again, this is interval notation. So this is like you're reading it left to right. It's going from negative infinity all the way to 4, just separated by a comma. But then the parentheses versus brackets tell me inclusive or exclusive. All right, so that was just a quick crash course on solving inequalities. Let's do another one. So if I had 4 minus 3x less than or equal to 7 plus 2x, I want to solve, don't need to graph this one, but I want to represent the answer in interval notation. Okay, so I want to get all my x's on one side and all my numbers on the other side. So this one, I would probably just add 3x to both sides, and then I'll subtract this 7. So I have a negative 3 is less than or equal to 5x. And there was nothing I had to do with the inequality symbol in terms of reversing it, because all I did was add and subtract. Now I want to divide by 5. So I have a negative 3/5. I didn't divide by a negative, so my inequality symbol stays in the same direction. So negative 3/5 is less than or equal to x. This one didn't say to graph on a number line, but let's just do it real quick to get an idea of what we're working with. So negative 3/5 is my number that I'm worried about. I want x values that are greater than or equal to that. So I know it's going to be a filled in circle there at negative 3/5. And I want x values greater than, so I'm going to shade to the right. Interval notation, I'm going to be going from negative 3/5 all the way up to infinity. I'm never going to include infinity, so that's always a parenthesis around infinity. But I am going to include that negative 3/5 because that can be a solution, so I put a bracket around that one. Okay, and again, this inclusive is going to come whenever you have greater than or equal to or less than or equal to. That's when you use a bracket. Parenthesis will just come from less than or greater than, but a parenthesis is always around infinity. Okay, let's look at a word problem, and specifically let's look at a break-even point. If R represents the revenue and C is the cost, then break-even is when R equals C. Okay, so it cost me $10 to make something, and then I get paid $10. I really break even. Okay, I didn't make any money, I didn't lose any money. Okay, if the revenue and cost of a certain product are, okay, there. If the revenue is R equals 4x and the cost is 2x plus 10, and x represents the number of units sold, at what production level does R at least equal C? Okay, so R is at least equal to C. What inequality symbol am I going to have between the R and the C? Okay, you got it? Okay, the equal to is correct. So R is at least equal to C. So the smallest it would be is C. So R is actually greater than. So that's the tricky part with inequalities, is making that connection of what is going on. So R is at least the smallest r would be c, otherwise r is bigger. So r is greater than or equal to c. So now let's actually fill in what our equations are. So this is really 4x is greater than or equal to 2x plus 100. Now I have an inequality that I can solve. If I subtract 2x from both sides, it's simply subtracting, so I don't have to worry about any reversing of that inequality symbol. So I'd have 2x is greater than or equal to 100. Divide by 2, divide by 2. So x is greater than or equal to 50. Okay, so now we have to put this in context. Okay, so the question asks, where R is the number of units sold, at what production level does R at least equal C? So I want the least number of units to be 50. I want 50 or 51 or 52. If I'm at 49, my cost is going to be higher than my revenue. So I want R to at least equal C. So I want X values that are greater than or equal to 50. 50 is my break-even point. I want 51 or 52 or 53. That way I'm actually making money on this. Okay? And so if I were to write this in interval notation, it's actually going from 50 all the way to infinity. Infinity would be a parenthesis. 50 I can include. All right. Again, this is an inequality, so it's not going to be x equals something. It's going to be a range of values. Okay. At what production level does R at least equal C? At 50 is my break even, but any number in 50, I'm at least equal to. Okay. I'm going to be actually bigger as I progress further, 51, 52, 53, and so on. Okay, last slide. 3-part inequalities, and these are compound inequalities, meaning that there are 3 parts. 1, 2, 3 parts to it. To solve compound inequalities, you want to break these up into 2 separate ones. So I would say -2 is less than or equal to 5 plus 3x. And I'd solve that. But then also 5 plus 3x has to be less than 20. So that creates my 2 equations that I need to solve. All right, so now I can solve each one individually. Subtract 5 from this one, subtract 5 of a -7 is less than or equal to 3x. Divide by 3, divided by 3, -7/3 is less than or equal to x. The one on the right, I'll subtract 5, so that's 3x is less than 15. Divide by 3 on each one. I'm not dividing by a negative, so I don't have to do any reversing of the inequality symbol. So x is less than 5. Now I have to put it all back together. I know x has to be greater than or equal to a -7/3, but then x has to also be less than 5. So let's just represent this with a number line real quick. So x is greater than or equal to a -7/3. I'm going to have a filled in circle here, and I'm going to be shading to the right. But then it's less than 5, so that's going to be an open circle, and that one's shading to the left. So this is what it would look like graphically if I want to write this all out as 1, I could say, well, negative 7/3 has to be less than or equal to x, which is also less than 5. I could rewrite the solution as a compound inequality. And then I can also write it in interval notation. Negative 7/3 all the way to 5. I'm not including 5 because that was an open circle, but I am including negative 7/3. So there's 3 different ways that we can represent the solution to this. So any number including negative 7/3 all the way up to 5, but not counting 5, will work. If I chose 6, this inequality, the original one in red, would fail. Okay, if I chose negative 10, it would fail. If I chose 0, yep, it works. It's still true. All right, so solving compound inequalities, separate it into 2 inequalities. This is an AND statement. It's negative 2 is less than or equal to 5x, or 5 plus 3x, and less than 20. You could have OR statements where it'll set up as 2 separate ones. And so I don't have an example of an OR one, but you've seen those before. So that's your options with compound inequalities. Okay, questions on any of those? All right, so your assignment is 1.7, day 1 in Math Excel. And it is due Tuesday before the start of class. Okay, so we start at 12:07, so make sure you have it done prior to the start of class tomorrow. You have the rest of the hour to work. Tomorrow we'll do day 2 of 1.7, and then we'll get ready for the quiz on Wednesday.